Hello guys, so today we're gonna solve this problem, magnetic force between the two balls. So basically what is happening here, we are given one position array. So that position array basically had the position value where a bucket could be placed. Okay, and in these buckets we have to put the balls. Okay, like this in this diagram you can say the ball is put at position 1, then 4, then 7. So similarly, we can put the m balls at any place, right? If the size is greater than or equal to m of the position. So what we have to basically do is, you can see here that Rick has n empty buckets. So basically this is talking about the position I, which has size n, and it has m balls. So need to distribute the ball into buckets such that the minimum magnetic force between any two balls is maximum. So what does it mean is, let me explain by the diagram. Okay, so see this number, minimum magnetic force between any two balls is maximum. So let me explain it first. What does it actually means? So see here, I have taken the example given in the question itself. So this is our position array and we have m equal to 3. So basically we have 3 balls and we can place these 3 balls anywhere, right? So we will, let's say I'm putting on these first two first of all. Okay, so I'm putting 1, 2 and 3. So what would be the magnetic force mf between first and 2? It would be basically the difference of their values. So 2 minus 1. So 2 minus 1, basically it would be 1. Okay, so difference between this and this. Now difference between 2 and 3, this is again 1. Okay, so magnetic force. Now the magnetic force between 1 and 3, it is equal to 3 minus 1. So basically it is 2. Now we can have this, these are the magnetic force. Okay, now out of these magnetic force, what is the minimum? 1 is the minimum. So we can put it here 1. Okay, now we can take another position. Okay, so take an example, we are putting them, let's say we can put 2, 3 and 4 place, right? So if we are putting here 2, 3, 4, so what would be the magnetic force? Between 2 and 3, it is 1. Okay, between 3 and 4, it is again 1. Between 2 and 4, it is 2. So again the minimum magnetic force in this position also, it is 1 only. Let's say now we are picking 1, 4 and 7. Okay, so what would be the magnetic force in this case? What would the, between 1 and 4 it would be? Between 1 and 4 it is 3, right? So first magnetic force is 3. So we are putting them here, here and here, m equal to 3. So 1, 4 and 7. So 4 minus 1, first one magnetic force is 3. Then we have 7 minus 4, this is also 3. Then we have 7 minus 1, this is 6. Now what is the minimum? Minimum here is 3. Okay, so we are putting it here 3. Now we can have multiple such positions. So let's go further some more. Okay, so let's say we are this time picking this one, 2, 3 and 7, let's say. Okay, so 2, 3, it is 1 only. 3, 7, it is 7 minus 3, which is 4. And then 2, 7, 7 minus 2, this is 5, right? So here also what it is minimum 1 is again 1. So similarly there could be multiple solutions, right? There could be multiple solutions and we will get those magnetic force. So out of those multiple solutions, we have to find which one has the maximum value. Okay, so in this case you can see 1, 1, 3, 1. So this should be basically our answer. Okay, this positioning is actually our answer because this is the maximum value. So now this should make sense that what does it, this line means. Okay, so this line, same thing it happens. See here, it is saying that distribute the balls into the basket such that the minimum magnetic force between any two balls is maximum. This is what I have just done. So 1, 1, 3, these are the minimum, and out of all these solutions, this 3 is the maximum. So minimum ka maximum is 3 here. So this is our answer. This is what we gonna do. Now we will proceed ahead how we approach for it. Now guys, think for a moment that let's say if I am dividing this line, can you see this line? If I divide this line in terms of d, okay, so if I'm equally dividing it at least d, okay, it should be either d or greater than d. Okay, let's say if I am dividing this line in this way, then we can say that minimum, if we do the magnetic force, the minimum would be d, right? Because this should be d, this could be 2d, but what I'm saying is basically the minimum should be the distance, should be the d on this line. So in this case, if we put our balls, then our min would definitely come d, correct? This assumption is very simple as that. Okay, so with this assumption you can visualize that if we try to make this d as much as possible and we put all the m values, all the balls on the position, we can find our answer. We should be very clear here. So with this idea, we can go ahead for the solution of this problem. So now let me again repeat. We are assuming, let's say this is our line. Line means suppose this is this array has 7 as the maximum, right? So 7 is the maximum. So you can consider if this is a line of 7, then we can find some d in such a way that we are distributing m, that at least d is the distance among any two balls, and it could be more than d. So in this way we can visualize that minimum would be our d. Okay, so minimum would be d and we have to maximize this d. So with this assumption, what gonna do is, let me explain it. So see here, anyway, first of all we put our walls. Let's say we are starting with this location. So anyway, if we put one ball here, okay, consider ball b1 here, then we have remaining value would be m minus 1, right? We have to distribute those m minus 1 in this remaining size, right? So what would be the remaining size? Okay, so what about the remaining size? If we divide that with the, let's say whatever the max size of this length, if we divide that max with the m minus 1, right? Because 1 is already placed. So if we divide it with this m minus 1, this will basically give us the d among all of these, right? Like this. Okay, so like this could be our d all or everywhere. Okay, at least d it would be. So if we divide in this way, what will happen? We will get one d value. Now we can go in a binary search way, okay, to get the maximum value of d. Okay, so what would be that binary search approaches? So we can start here with our, let's say we were starting with our start could be here. We can have two variables, start and end. Okay, so this start would be 1 basically, because after we are starting, because any d should be at least 1, right? And end would be the maximum value in this array, so 7 in this case. Okay, so now what will happen? We will get the value of mid first of all. So mid would be basically the start plus end divided by 2. So in this case it is becoming 3, right? Now we will see that if with d equal to 3 means if can be place all the values with m equal to 3, right? But see here, if we go to the gap of 3, okay, then it would be overflowed, right? Because we have m equal to 3. So in this case it would not be able to place all the m's, right? So in this case we have to maintain that either we have to update start or end. So what will happen in this case? Because we are not able to do it, so basically we have to increase our end, right? So what would be the approach here? Sorry, we have to increase our start, right? Because we have to decrease the m, basically the d value. So if we decrease, that means start should be mid plus 1 now. Similarly, if it is able to accommodate m equal to whatever value, in that case we have to update our this value. So in that case our our end would be basically become mid minus 1, the usual binary search. So let me execute one code that will make the things very clear. So as you can see here, this is our array. Okay, so start equal to 1. So let me clear one thing. This start and end, basically these are the distance which might be possible. So this is not any index of this array. this start is like basically the minimum distance could be between two balls starting with 1, right, and greater it could be anything. Okay, now you can see here end equal to this max value is 7, right? So 7 divided by m minus 1. Okay, because one ball is being placed on the very first location, so we were doing right like this, right? So these start is initially it could be 1, but remaining it could be up to this thing, right? Whatever the maximum value 7 divided by whatever we have, right, m minus 1. Okay, so this could be, this is just a distance between the possible distance between the balls. So don't get confused whether these start or end are the index. No, not at all. These are the space that might be possible up to this end, 7 divided by m minus 1. Okay, so then we will proceed ahead. Now we will calculate our m just like we do in our usual thing, right? So mid is equal to start plus end. So it would be 1 plus 3, right? Here it would be 3. 7 divided by 3. So 1 plus 3 divided by 2. Basically it is becoming 2 only. Okay, so mid would be 2. Now this 2 is the space. Okay, now we have to check whether can we put the remaining walls with space 2. Okay, so for example here now we will traverse with this. Okay, so take an example 2 minus 1. This is 1. So this is less than this distance. So we cannot pick 1 and 2. Now come here 3 minus 1, which is 2. So this can be possible, right? 3 minus 1, which the space become 2. So we can place ball here. We can also place ball here. Now this is the latest where we have made this placement. Now come to here. 4 minus 3 is 1, which is less than this space mid. So we cannot pick 4. Now come to here 7. So 7 minus 3 it is basically 4, which is greater than or equal to mid. So this also satisfies. So 1, 3 and 7 could be the one possible way of doing it. Okay, so also this would be lead to our answer as well, right? Because mid equal to 2, it is giving us the this value. Because if we further increase the mid value, so this would be not working. So let me further explain it. So now after doing this, so basically we have placed the values. So this is first for m equal to 2, it is basically true that we can place. So now our tendency should be to maximize this distance, right? We want to maximize the minimum. So our tendency should be further increase. Okay, so what we will do is, in this case we have to basically increase the start. So start would become our mid plus 1. Okay, so start would be mid plus 1. Okay, so say it is mid plus 1. So we will check for this value now. So mid is equal to 2, right? 2 plus 1 it is 3. Okay, and end is still 3. So 3 plus 3 divided by 2, which is basically 3. So now our new space is coming as 3. Okay, so for this 3 we will check. So first one is always already 1, right? So we will 2 minus 1, which is 1 only. So we cannot pick this. 3 minus 1 also it is 2 only, which is lesser than 3. So we cannot pick. Now 4 minus 1 is 3. So we can pick this, right? 4 minus 1. So 1 we can pick, 4 we can pick. The distance is 3. Now 7 minus 4 also 3. So we can pick this as well. Okay. So this is also the 3 valid positions where we can put the values. Now see what would be the power here. 4 minus 1 it is 3. 7 minus 4 it is 3. Okay, and 7 minus 1 it is 6. So what is the minimum? Minimum here is 3, which is again becoming the maximum. Now if we go further, because we are still getting true here. Okay, so if we are still getting true, that means we have to again increase our our start value, right, with mid plus 1. So mid plus 1 it would be 3 plus 1, so 4. Start would be 4 and end is still our 3. So this would be violating our condition, right? We have to traverse only till start is less than or equal to end. So we would be ending here and our answer would basically mid equal to, what is that? Yeah, so with this space 3 we were getting the answer. So 3 should be our answer. Now you would be crystal clear with this solution. Now let me write down the code of it so that things would be very, very clear. So see here. first of all I have written one boolean function, is m ball placed. So this basically, this d is the distance, right, space which we are looking for. Like in the binary search we will pass the mid value, right? So this d is the space and this is position and m. Okay, so initial position is position 0, right, and ball placed is 1 because on position 0 we have placed 1. Now what we were doing is, starting from the second I equal to 1, we are traversing till m is less, so this ball placed equal to 1, so till it is less than 1 we are going here. So see here, what we are checking, we are checking whether the difference of the positions is greater than or equal to d or not. Okay, this is what we were doing here. So if it is greater than or d, that means it is a valid move. We can ball placed, we can plus plus because we are putting that well here. And now our new initial would be current position, and we will proceed in this way. And finally we will check that if ball placed is equal to m, that means all placed, that means it is returning true, otherwise it will return false. Now this utility function would be used in our binary search. Okay, so let me show that code as, so see here, this is our binary search code that I have written. So max distance, so first of all we are basically sorting the position array. Then we are starting, so start is 1 for the same reason I told you that start is the 1. So 1 is the minimum distance between any two position, right? 1 is the space at least. Okay, so we are starting 1 space, and this end should be position n minus 1, means the largest value divided by m minus 1, because one position is already placed, so we need all those things. So this end would be, again, these start and end are the space possibilities. Okay, now see here, we are doing just binary search and we are calculating this mid basically. And now we are looking for this, is m ball placed with this mid. Okay, this mid is the space. So we have written, we were doing, so that we have written that function on top of it, right? So if it is placed accordingly, that means we have still some possibility that can be further increase this minimum value. So that is why I'm increasing that start is equal to mid plus 1, because our tendency is to further maximize the minimum values. Okay, so in that case we will again make start is equal to mid plus 1. If it is not true, means if with the mid space we are not able to position all the m, that means we have to basically decrease the space. So for that reason I am making this end is equal to mid minus 1. And finally in this answer I am every time storing this mid value. So finally when we will come out of this loop, our answer would be having the actual value. Okay, so let me execute this code and then we would be further proceed. So I'm running this code. Yeah, it is working. Let me submit it. I already actually checked it, but I'm still doing it. So it is accepted with 97.32% faster. So thank you for watching the video, and if you have any concern, please make a comment over there.